Hi students, now we are going to see the acidity of carboxylic acids. Acidity of carboxylic acid means acid. What is acid? A substance which has a tendency to give which ion? H plus ion. Acid which have a tendency to give which ion? H plus ion. Now we are studying about the carboxylic acid. The carboxylic acid undergoes ionization. What is ionization? It has a tendency to produce cation and anion. Cation carries which sign? Plus sign. Anion carries which sign? Minus sign. Anion carries which sign? Minus sign. So carboxylic acid undergoes ionization. It has a tendency to give ions to produce, that is, what are that ions? Carboxylate ion in aqueous solution. Carboxylate ion carries which sign? Minus sign. Carboxylate ion carries which sign? Minus sign. The carboxylate ion is stabilized by resonance. What is resonance? If one structure cannot able to explain the nature of that substance, means we can write in different structures. That structures explain about that compound. So the carboxylate ion is stabilized by resonance, which have the carboxylic acid to donate proton easily. That means carboxylate ion means 8. After the removal of hydrogen, the compound is called as 8. Here it is carboxylate. Carboxylate ion is nothing but after the removal of H plus ions in carboxylic acid. Now let's see this carboxylic acid. General we are taking on carboxylic acid, that is RCOOH. Carboxylic acid. Acid which means have a tendency to give which ions? H plus ion. So H plus goes out means this becomes minus. After the removal of H plus ions, the compound is called as a carboxylate ion. The compound is called as a carboxylate ion. Now we are going to see the resonance structure. We already discussed, no? It is stabilized by resonance structure. What is the resonance structure? Carboxylate ion. This is nothing but a carboxylate. Carboxylate. 8 means after the removal of hydrogen. This carboxylate ion, this minus, how the resonance structure? Resonance means this symbol you have to put between two compounds. That is, if the two structures, if the bond shift here means this carbon is already satisfied with 4 valence. You know what is the valency for carbon? It is 4. What is valency? What is valency? Valency means number of electrons in the valence shell. So number of electrons in the valence shell. Carbon, what is its atomic number? 6. How to write the electronic configuration? 1s2, 2s2, 2p2. This is the outermost shell. How many electrons is there? 4 electrons. So what is the valency for carbon? 4. So if the minus comes here means the carbon is already satisfied with 4 valency. So it has to shift one bond to another atom. Here it oxygen, it is highly electronegative. So it has a tendency to accept the electron. So this bond comes here means double bond. This shift here means O minus. This resonance is equivalent to this one, that is minus is common to both of these oxygen atom. This is symbol represents the equivalent. This symbol represents the equivalent. Now we are going to see the strength of carboxylic acid. The strength of carboxylic acid was explained by dissociation constant. Explained by the dissociation constant. What is the symbol for dissociation constant? Ka. Symbol for dissociation constant is Ka. That is RCOOH react with water. That is aqueous solution. We already discussed, no? So aqueous means water. In acid, which has a tendency to give. Acid means which has a tendency to donate the H plus ion. So this oxygen accept this H plus ion and form a H3O plus. Remaining is RCOO minus. So if an equilibrium exists means we can write the equilibrium constant, no? We are writing for acid. So A symbol is there. So Ka equal to product concentration by reactant concentration. Why don't we put this water molecule here? Water is in excess. Water concentration, we always take this in excess. So its change is negligible. So its change is negligible. So no need to mention here. So now the Ka is nothing but dissociation constant. Ka is nothing but dissociation constant. Now the dissociation constant is generally called as acidity. This Ka value represents the acidity. Ka value represents the acidity of the carboxylic acid. Ka value represents the acidity of the carboxylic acid. So the dissociation constant is nothing but which represents the acidity. The constant, that is because it measures the relative strength of the acid. This acidity constant. So Ka represents the acidity. A acid, K constant. So equilibrium constant, no? So acidity constant because it measures the relative strength of the acid. It represents the strength of the acid. So Ka increases means acid strength increases in that manner. Stronger the acid, higher will be the value. So stronger the acid means higher will be the value. Which value? Ka value. Ka value increases means what is? Ka also expressed in pKa. Ka value increases means acid strength increases. Ka value increases means acid strength increases. Ka value increases means acid strength increases. So Ka value increases means acid strength increases. So Ka can be represented in pKa. We already discussed, but that is pH, no? So pH. For acid, pH value we discussed, no? pH. What is pH? What is pH? If the pH value is less than 7 means acid, we discussed, no? That means H plus is 10 power minus 7. So similarly, Ka value increases, acid strength increases, but pK value decreases, acid strength increases. So pKa can be written as pKa equal to minus log of Ka. pKa equal to minus log of Ka. A stronger acid will have higher Ka value and smaller pKa value. A stronger acid will have higher, that means Ka value increases means acid strength increases, and the pKa value decreases means acid strength increases. So Ka value increases, acid strength increases. In pKa means it must decrease, then the acid strength increases, So this is the acid nature with the equilibrium constant Ka, that is acidity constant. Now effect of substituents on the acidity of carboxylic acid. Effect of substituents on the acidity of carboxylic acid. Effect of the substituent. If any group attached to the acids, then it has a tendency to affect its acidity. So if acetic acid, no, CH3COOH. If one Cl is added there, CH to Cl, no, we already studied in HVZ reaction, alpha halo. That type of any substituent is there means it has a tendency to affect the carboxylic acid. How it affect the carboxylic acid? Electron releasing alkyl group. If any electron releasing alkyl group, electron release, name itself mentioned, electron is released from that group. So electron releasing alkyl group is there means it decreases the acid strength. Electron releasing group means alkyl, chlorine, alkyl group. So now alkyl aryl, electron releasing alkyl group, here it is mentioned alkyl, so it has a tendency to decreases the acidity. Electron releasing group is represented by plus I. Electron releasing can be represented as plus I. That means plus I group increases means the negative charge on the carboxylate ion. That means the electron releasing plus I increases the negative charge on the carboxylate ion. That means electron carries negative sign. No, if it is released, that compound carries excess of electrons. So carboxylate ion negative sign increases. This destabilizes the carboxylate ion. This destabilizes the carboxylate ion. Hence, loss of the proton becomes difficult. Concept: electron releasing group increases means the loss of the proton difficult. What is loss of the proton? Acid means which has a tendency to donate the proton, no, H plus ion, then only it is acid. If it becomes difficult means it is a weak acid. That means acid strength decreases. Loss of the proton means acid. That is, what is acid? It has a tendency to donate H plus. If it is a strong acid means it must give the H plus ions. It becomes difficult means it is a weak acid. Similarly, let us see one example. CH3COOH. What is the name of this compound? It is nothing but acetic acid. It is nothing but acetic acid. Acetic acid. So now, acetic acid. This is our carboxyl group. This is COOH is our carboxyl group. CH3 is our alkyl group. Alkyl group which has a tendency to donate the electron, no? So this alkyl group donate the excess of electron to this carbon. This carbon becomes excess in negative charge, excess electron. So it donates to next oxygen, next atom which is oxygen. This further donate to hydrogen. This further on donated to hydrogen. Now, therefore, electron density increases. Therefore, electron density increases. Alkyl group is a electron releasing group. Electron releasing group. Therefore, what happens? Electron density increases. Electron density increases in hydrogen. This hydrogen, the oxygen shifts to hydrogen. Therefore, hydrogen has more electron. Hydrogen has to be removed. But this carboxyl group donates electron to hydrogen. So, whether it has a tendency to move or not? No. This H plus is well settled here because of the excess of electron. To remove the H plus, it is difficult. Therefore, the acid strength decreases. So, the alkyl group increases means it has a tendency to donate the electron. This donate to oxygen, this donate to hydrogen. If it is a strong acid means this H plus should be removed. Instead, here it is well settled by accepting the electron. So, alkyl group increases means acid strength decreases. Acid strength decreases. Now, compare some of the acids. Acetic acid, formic acid, propionic acid. Comparing these three, which is more acidic? Find out. The alkyl group increases means acid strength decreases. Leave this carboxyl group. Find the remaining carbon. Here didn't have any carbon, only one carbon. Here 2 carbon atoms. Alkyl group increases means acid strength decreases. So, which is more acidic? This formic acid, since it does not have any alkyl group. And the next is acetic acid, since it have only one alkyl group. And the next is propionic acid. Yes, this is the order: formic acid, acetic acid and propionic acid. Formic acid is more acidic, acetic acid is acidic, but propionic acid is less acidic. This explains the alkyl group increases means acidity decreases, acid strength decreases. Alkyl group is nothing but it is electron releasing group. So, commonly we must understand electron releasing group increases means acid strength decreases. Electron releasing group is nothing but the alkyl, methyl. Carbon increases, number of carbon atom increases means acid strength decreases. So, now we finished the electron releasing group. Now, what about the electron withdrawing group? What about the electron withdrawing group? Electron withdrawing group in the substituent. If the electron withdrawing group is the substituent means what happens to the acidity? What happens to the acidity? Electron withdrawing group increases means decreases the negative charge. If it is a releasing means increases. It is withdrawing. That means accept. So that means accept means remove the electron from hydrogen. So here it decreases the negative charge on carboxylate ion and stabilizes it. Now therefore loss of the proton becomes easy. Therefore H plus easily removed. The electronegativity of the substituent increases means acidity. What is electronegativity? Which has a tendency to accept electron. So electronegativity increases means acidity decreases. Electronegativity increases means acidity increases. Now compare these three. Fluorine, chlorine, bromine, iodine is substituted in the acetic acid. What is acetic acid? If instead of hydrogen, iodine, if we have a hydrogen means it is acetic acid. This is fluoro, monofluoro or alpha fluoroacetic acid, alpha chloroacetic acid, alpha bromoacetic acid, alpha iodoacetic acid. Fluorine, chlorine, bromine, iodine. What about the electronegativity order? Fluorine is more electronegative than chlorine, than bromine, than iodine. Fluorine, chlorine, bromine and iodine. This is the electronegativity order. So based on this we have to explain this also. Since fluorine is more electronegative, it has a tendency to accept the electron. So hydrogen electron get accepted and remove the hydrogen as a H plus, then less than chlorine, then bromine, then iodine. So electronegativity increases means acidity increases or acid strength increases. Now we are going to see the electron withdrawing, number of electron withdrawing substituent. We know electron withdrawing group increases means acidity increases, but the number of electron withdrawing group, that is more number of electron withdrawing group is there means then the acidity increases. Here 3 Cl is there, 2 Cl is there, only 1 Cl, no Cl. Which is more electronegative? Chlorine is more electronegative. How many electronegative atoms here? 3. So the number increases means acidity also increases. Number increases means acidity also increases. Now electron withdrawing group on the acidity of the carboxylic acid follows. Electron withdrawing. NO2 is always plus, electron deficient. NO2 plus, we discussed no, nitronium ion. NO2 plus is nothing but a nitronium ion. Nitration. NO2 plus. This is Cn. This is carbon is also electron deficient. So fluorine, chlorine, bromine, iodine, all these have a tendency to accept one electron to attain the stable configuration. So all these electronegativity is -1. It need one electron to become stable. So these are highly electronegative, and then the phenyl group, Now the relative acidity of various organic compounds. This is about the electron withdrawing group. Here various organic compound. If acid is there in the compound means it is more acidic. And then aryl, aromatic alcohol, water, aliphatic alcohol, acetylene is also a acidic tendency. It also have a acid tendency. That means it has a tendency to give the H plus ion. It have a tendency to give the H plus ion. And the next is functional derivatives of carboxylic acids. Functional derivatives. Acetic acid formula CH3COOH3. So group replacing OH group instead OH group, if you substitute Cl means it is called acid chloride. Formula instead of, consider this as a CH3 COOH. Instead of OH we placed here is Cl. So this is acetyl chloride. Acid derivative, acetic acid derivative, no? So acetyl chloride. And NH2. Instead of OH, if you put NH2 means it is called acid amide. Amide we already discussed, no? With ammonia. So NH2 amide. Acetic acid derivative, so acetamide. Acetic acid derivative, so it is acetamide. And O R dash is substituted instead of OH. Instead of OH, what is substituted here? O R. What is this R dash? This is R and this is R dash. If it is a methyl means it is ethyl. Different alkyl groups is mentioned in this manner. R dash. CH3, COO, CH3. Here it is same. Methyl acetate. Acetate. Methyl. You have to, while writing the ester, find out which alkyl group is attached to oxygen. Which alkyl group is attached to oxygen. First write the alkyl group and the acid name. Acetate. And the next is acetic anhydride. OOCR. That is acid anhydride. Acid anhydride. This is anhydride. That is, we already discussed acetic anhydride, acetic acid with P2O5. It is a powerful dehydrating agent. Intermolecular dehydration we discussed, no? So, inter means between. So, we get this anhydride. What is anhydride? The compound obtained after the removal of water. Compound obtained after the removal of water. So, take to acetic acid. After the removal of water, we get this compound. This is nothing but acetic anhydride. Anhydride means compound obtained after the removal of water. Acetic acid derivative. Now, relative reactivity of acid derivatives. Relative reactivity of acid derivatives. What are the acid derivatives we discussed? Acid chloride, acid anhydride, ester amide. Acid chloride, acid anhydride, ester amide. Acid chloride, among all these, acid chloride is more reactive. Amide is least reactive. Order. This order can be explained on two terms. Basicity of the leaving group, resonance effect. Basicity of the leaving group and the resonance effect. What are the two terms which explains the reactivity of this acid derivative? Basicity and resonance. Basicity and resonance. So now, basicity of the leaving group. Basicity. What is basicity? Available of lone pair electrons. Increases means basicity increases. Availability of lone pair electron increases means basicity increases. Weaker base. A compound is a weaker base or group is a weaker base means it is a better leaving group. And the reverse is the reactivity. Stronger base means can't able to leave and its reactivity is more. Hence, acyl derivatives. Acyl, it is nothing but acid derivative. CH3CO, whether it may be Cl, NH2, anhydride, ester. With the weaker base as leaving group can easily rupture. What is rupture? Break. Break the bond and are more reactive. If the acid derivative is weaker base means then the rupture the bond and becomes more reactive. Now correct order of the basicity of the leaving group. What is leaving group here? NH2. I already mentioned, no? The availability of lone pair. NH2, OR, RCOO, halide. This is acid halide, acid anhydride, ester amide. Ester or anhydride? Ester. So acid halide, acid anhydride, ester amide. This is the basicity order. This is the basicity order. The reactivity is reverse. Acid halide is more reactive. This is basicity. What about the reactivity? Is reverse. Cl greater than, RCOO greater than, OR greater than, NH2. This is the reactivity order. So now next factor is resonance. We already discussed the two terms. One is basic nature, another one is resonance effect. Resonance, electronegativity decreases means resonance stabilization increases. Electronegativity we already discussed. Tendency to Accept electron decreases means resonance stabilization increases. So this effect make the molecule more stable. Stabilization, resonance is there means that molecule is more stable and reduces the reactivity. Stable means it can't able to react, no? So reactivity, electronegativity decreases means stabilization increases. That is resonance stabilization increases. Stable compound can't able to react readily. So now the order of the electronegativity of the leaving group is chlorine is more electronegative, then ester, anhydride, ester, amide. So the important one mark, what is the reactivity order of acid derivative? Acid halide, acid anhydride, ester, amide. Acid halide, acid anhydride, ester, amide. So these are the reactivity order of this acid derivative. Now we are going to see the IUPAC name. Now we are going to see the IUPAC nomenclature. Nomenclature is nothing but naming. Nomenclature is nothing but naming. Now how we are going to name the compound, that is acid. Two names are there, common name and IUPAC name. Now we are going to see the IUPAC name. While writing the IUPAC name, first you must write the prefix and then root word and then primary suffix, then secondary suffix. What is prefix first? It is nothing but the substituent. Find, if one compound is given to you to write the IUPAC name means first find whether there is any substituent or not. If there is any substituent means write that first. So now write the substituent. Prefix is nothing but the substituent and write the number of carbon, the number of the carbon to which it is substituted. First we have to write the substituent along with the position, which carbon. So while writing the name, first you must write the substituent. Find whether there is any substituent or not. If there is any substituent means write that first along with the number to which the substituent is attached. And the next is root word. Root word means find the longest chain. First we must number the compound, no? How many carbon atoms there? That is root word. The number of carbon atom in the parent chain. What is the parent chain? How will you find the parent chain? You have to put the number and find. You have to put the number in 2 or 3 more possible ways and find the longest chain. That longest chain is called as a parent chain. In this parent chain, how many number is there? If 4 carbon is there means it is butane. 5 means pentane. 6 means hexane. That is the root word. First you have to write the substituent. Then write the parent chain, whether it is but or hex, pent, etc. Primary suffix. What is primary suffix? Find out whether the compound is saturated or unsaturated. What is saturated? Saturated means only single bond. Alkane is there. Unsaturated means it may be alkene or alkyne, whether the compound containing double bond or triple bond. Here we find but means if it is only single bond means butane. If it is double bond means butene. If it have a triple bond means butane. So while writing the IUPAC name, first you must write the prefix. What is that prefix? Substituent. What is that root word? Next to root word, no? What is that? Number of carbon atoms in the parent chain. Find whether it is hex, but, pent, etc. Primary suffix alkane, alkene, alkyne. Secondary suffix is nothing but the functional group. If it is alcohol means the name should end with OL. Aldehyde means AL. So this is the simple to write how to write the IUPAC name. So first write the substituent, total number of carbon and alkane, alkene or alkyne and then functional group. Now we are going to see what are the functional groups we are going to see here. The functional groups are acid halide. Acid halide is there means oil chloride. If you have CH3 here means CH3 means this is acetyl chloride. How many carbon atom is there? 2 carbon. So ethanoyl chloride. Name should be written as ethanoyl chloride. This group is called anhydride, no? IUPAC name should be end with oic anhydride. Oic anhydride. And if ester is there means O8, methanoate, ethanoate. In this manner you have to write. CONH2 means amide, acetamide, along with the acid derivative. Acetamide, propionamide. In that manner, propanamide. In that manner you have to write the name. First, let's write the simple compound name for our given compound. That is CH3, CH2, COOH. How to write the IUPAC name? First you have to write the prefix, root word, primary suffix, secondary suffix. What first you must find the substituent. Prefix is nothing but a substituent, no? Whether we have any substituent here? Prefix is nothing but the substituent. Find out whether any substituent is there in this compound. No. So no need to write this. Root word means find the number of carbon. 1, 2, 3. How many carbon atoms is there? 3 carbon atoms. 1 carbon there means methane. 2 means ethane. 3 means propane. So write prop. Find out the primary suffix. Whether these compound have any double bond, triple bond or single bond. Only single bond is here. Then it is ane. Propane. Secondary suffix last. Find the functional group. Find out the functional group. What is the functional group here? It is carboxylic acid. Acid means name should end with oic acid. This is oic acid. So no substituent. So no need to write a prefix. Prop, root word. Ane, single bond, no. So it is primary suffix. What is our functional group? Carboxylic acid. So oic acid. In this manner, we are going to see some compounds, common and IUPAC name of our acid derivative. Here it is. Acid derivative common name, IUPAC name. Acid derivative common and IUPAC name. That is CH3 COCl. CH3 COCl. What is the name? And the common name is written in the acid derivative. From which acid derivative it is obtained? From which acid derivative it is obtained? In that manner, you have to write the common name. So CH3 COCl. It is nothing but acetic acid derivative, no? So acetyl chloride. So it is acetyl chloride. How many carbon atom is there? 1, 2. COCl means oil chloride. 2 carbon means ethanoyl chloride. Ethanoyl chloride. And the next we are going to see is CH3 CH2 COCl. COCl we know oil chloride. How many carbon atoms is there? 3 carbon. So propionyl. Propio common name. Propionyl chloride. How to write the IUPAC name? 3 carbon atoms. Propane. IUPAC. Propio common name. Why prop? 3 carbon atoms. So this is the acid derivative. Next compound is C6H5. Phenyl. Benzene ring is attached here. In the benzene ring, if you remove one hydrogen, it is called phenyl. But along with the CO, it is called benzoyl. C6H5CO is called benzoyl. What is here? Benzoyl chloride. This is benzoyl. What is this? Chloride. Benzoyl chloride. Common and IUPAC name are same for benzene compounds, aromatic compound. So now we are going to see the next compound CH3CO. CH3. This CO is nothing but anhydride. Which acid? Acetic acid. So acetic anhydride. What is that? Acetic anhydride. How many carbon atoms is there? 2 carbon. This side 2 carbon. So ethanoic anhydride. Anhydride is obtained by taking 2 compound, no? 2 carboxylic acid. So ethanoic anhydride. Ethanoic anhydride. And the next is CH3 CH2 CO CH. This is also anhydride. This represents the anhydride. This how many carbon atom is there? 1, 2, 3 carbon. Propio. So propio. Anhydride. Propionic anhydride. IUPAC name propan. Propanoic anhydride. Propanoic anhydride. Phenyl group. C6H5. Benzoic anhydride. Common and IUPAC name are same for the acid derivatives, no? So it is benzoic anhydride. Next we are going to see the ester. Next we are going to see the ester. What is the ester functional group? COO is our functional group. COO. COO ester. CH3 means acetic acid derivative. Instead of this methyl, if you have hydrogen means it is called acetic acid. If you remove one hydrogen means it is called acetate. What is attached here? Methyl. So, in ester, how to write the IUPAC name? Find whether which group is attached to oxygen. Which group is attached to oxygen? Which group? Methyl. So, write first methyl. See here, this is ethyl attached to oxygen. So, ethyl. See here, this is phenyl attached to oxygen. So, phenyl. So, while writing the ester, first how to find the name? Find first which alkyl group attached to oxygen. So, methyl. Methyl. Which acid? Acetic acid. So, acetate. How to write the IUPAC name? Find totally how many carbon atoms there. That is methanoic acid, no? So, this is methyl. Acetic acid. 2 carbon. Ethanoate. Methyl ethanoate. And the next, how to write the common name? Find which group is attached to oxygen. Ethyl. Which acid? Acetic acid. So, acetate. And the next is ethyl. How many carbon atoms is there? 2 carbon. Ethanoate. Ethyl ethanoate. How to write the common name? Find which group is attached to oxygen. Phenyl. So, phenyl. Which acid? Acetic acid. So, acetate. And phenyl. Phenyl. 2 carbon. Ethanoate. If it is 1 means methanoate. 3 means propionate. Propanoate. Like that. Now, our last functional group is amide. Last functional derivative is amide. So now, what is amide? CONH2. Which acid? Acetic acid. So, acetamide. CH3 is there, no? So, acetic acid derivative. So, acetamide. How to write the IUPAC name? Find the number of carbon. 1, 2. So, ethane. Amide. How to write the IUPAC name? 2 carbon. So, ethane. What is this functional group? Amide. So, amide. The next is CH3, CH2, CONH2. We know CONH2 is nothing but amide. How many carbon atoms is there? 3 carbon. So, propio. Yo. Common, no? So, propio. Which group? Amide. While writing the IUPAC name, propio can be written as propan. So, propanamide. Last one is, that is phenyl. C6H5, COCN, NH2. We know this is amide. C6H5CO is called benzoyl. We discussed, no? So, benzamide. Benzamide. Common and IUPAC name are same for acid derivative. Common and IUPAC name are same for acid derivatives.